Alright, welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. We are still implementing the unassemblize tool, which is a bigger tool, a lot of work. Last video we have concluded or made the printing for C++ source code and assembler bytes. We finalized that. Here. Okay, so can we submit this in chunks or do we do it all in one swoop? Instead of doing it like this here, I think we can also do it differently. Here in sized array, we make here an alias using max size equals size. Okay. And then here we put this uint back here and 11 here. And then we search for where this is accessed. Here. Then we do bytes max size. Oh, that doesn't work. Why not though? Yeah, because yeah, we would have to we still need an alias here. Bytes using bytes. I call it bytes array. Then it's bytes array max size. Oh, that doesn't work either. Oh, because why? Oh, right. Static const expro size type max size equals size. I think it has to be like this. And then this works. And now the question, does this work as well? No, that doesn't work. It's too bad. Okay, but this now works. Yeah. I think that's a little bit better. There's a to-do optimize struct layouts. Yeah. We have a lot of 64 bits whole. Just because of these two bulls, yeah. Yeah. I don't know. We can also add a function here. Get line index returns when invalid. Get line index const return line number -1. Yeah. And then here, line index. To the get line index. Yeah. Okay. Yeah. How do we make that smaller? I don't know. It's I mean, realistically, we could truncate the address because it's very unlikely that it will be so large. The address. But it's a bit dirty. would be nice to get rid of this here. I don't know. If this had just one less bytes, then it would be fine. Yeah, I don't know. Yeah. I don't know how to organize, how to optimize this. Let's remove this for now. Good. So we have bytes array. Maybe so common types. Array is set. I think we just do it all in one swoop. It's clean enough. Yeah, okay, so this looks good. PDB reader. This is also good. Let's just rename it. Here we fixed this problem, yeah. Downcast. Yeah. Rename. Actually, here we can do some splittings now. Let me get back here. So here we can do this. Then we do this. This asserts. And this. Is it downcast used anywhere else? No, just there. Okay. Good. So here we say reduce size of PDB reduce data size of that class struct. Okay. Then let's stash, compile. Okay. Then we do stash pop. Okay, then next we do this here. We just did a string to index map. We renamed this. Yeah, so we just here fix 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 functions claiming undecorated symbols. Fix functions claiming wrong undecorated symbols in PDB redirect compilant function. Fix functions claiming wrong undecorated PDB symbols in that. Fix functions claiming wrong. Okay, this should work. Commit. Okay, then we do a stash again. Then we compile that. Good. Then stash pop. And next. The sized array, I think we can do this separately as well. If we just find all the users. So it's this one. And not this yet. Here, this. And this. String to index map. Where's this used? Here's a match. Runner. I think we just staged this one. So we remove that string to index map t. Here. We have it here. Sized array. Sized array. Yeah, I think this is a split. And so this is both sized array and string to index map t to common types header. So sorry, template. It's alias. Okay. Good. We can commit this. Stash. Compile. Okay, that works. Then stash pop. Okay, next change. We do here we did some fix, didn't we? Let's ignore. Yeah, we just added this condition here. Fix prevent wrong reads of empty file in main. Prevent wrong read of empty file. Read attempt of void file name from empty file name. Prevent read attempt from empty file name. Prevents read attempt from empty executable file name. Okay. Good. There is this here, which I've added yesterday quickly after video. This function match collection. I wonder if we should break this guy. So what if we don't have this thing and instead we just use this, because that's how it's used for the most things anyway here. Build comparison results, because here build comparison results, we're just using bundles and matches. We are not using the map, so we shouldn't pass it either. So what I'm thinking is here we put this well, the collection makes sense because it bundles these two together, because they belong together. But this one here, yeah, it also belongs to matches, but it's not strictly required. Function match collection. Yeah. So here's the only time we actually pass a collection as a whole to a function. I would say for now we break it up. So we will So we'll simply remove this guy. Remove this. And ASM printer. No. Runner. Then ta-ta. And okay. Then here, move this as well. There we go. Good. So yeah, so no more collection. Just that. Yeah, we just have a bunch of functions to build all these in steps. Yeah. Yeah, I think that's fine. Good, then we can remove this as well. Okay, so we remove this guy. Function pair. This thing here, function pair. I guess here we can add an assert that this is not expected to be null pointer. What we can also do here is make a sub loop for size t I0, I smaller 2, plus plus I, and then we make it here a little bit more dense. Put here I, source file. Okay. And then we do the same here. Move this out. Well, is this necessarily easier to read? I don't know. There's something to say about the simplicity of the thing before. Like, I mean, this is also not too bad, but you need to do the mental gymnastic that this is there twice because we have this array, this loop. We can maybe simplify this. Do function pair. Which gives us const function, and then we just do function, get that. Oh, no, that doesn't work because of this index here. I kind of like it unrolled like this. Kind of makes it easy to read. You know, the loop doesn't give much advantage in readability. So I actually prefer this. Because it allows you to see like both things in the debugger in one go, right? You just put a breakpoint here, and then you can see both values easily. So it has some advantage. Good. Then we can move on. Okay. Buffers. Okay, this is all new. Functions, this is all new as well. Yeah, function type. Runner. This one we can make separate. Oh, here we have another alias. Yeah. Oh, let's not worry about it now. Okay, let's take these. Yeah. I don't know if we can easily make it separate. Let's see. F stream. No, we should not, because there's more dependency. Let's make it all part of the same. Okay, let's... Yeah, I would say the rest we just do one big change. Okay. So, function types. Yes. This, maybe we don't need this assert header, but okay. Okay, here we do a forward declare and then pass it here as references. Why is this here? I think we can also clear this here. Swap. Oh. Okay, then this should be fine. Set bytes, yeah. Okay. ASM printer, buffers. Yeah. And then this, yep. ASM printer. Yep. Here we did a lot of changes. Yeah, there's a lot of changes here. Okay. Okay, ASM matcher types, we removed that. We added the function pair. We changed the string pair type. Added text file content. Maybe text file content. It's a bit weird that we have name. Maybe we should rename this to text file. Yeah, just file name. Then we remove this. Okay. Then we this file name and the comparison result function pair functions. Okay. Fstream file content storage functions. Yeah. Okay. Fstream. Yep. Mm-hmm. 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 Mm. Okay. Okay. Right. Okay. 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 And file content storage. Find content, load content, size clear. Yeah. And our functions. Okay, that's it. Good. Let's run this once more before we commit to see if it actually still works. Yeah, it still works. Good. Then implement source file and assembler raw bytes. Associate source file lines and raw bytes to instructions and print them in comparison reports. Okay, very good. Then I think there is one more thing I would like to do in Runner. So we have these template functions sitting here somewhere here. PB reader. I wonder if these guys should be just just a private function, static function. Where are they used? Build bundles. Build function bundles. Build function bundles. Build function. Here. Yeah, let's take this guy. Yeah. Put him here. And this guy. Put him here. Make it static. Static. Okay. That's. And it's the wrong location. Here. Bundles. Functions. We rename this. And yeah. Good, and then we go here. And we make this runner. Build bundles. Remove the namespace. And we move it to here. Okay. Okay, then we take this guy and yeah. So this will be remove functions from anonymous namespace to runner class. Move template functions from anonymous namespace to runner class. Okay, it still compiles, yeah. Okay, and now next thing, we would like in our ASM printer. So we have here this codelen, linelen. I think we just make codelen customizable. Linelen, yeah, not so much. Codelen. Linelen. Well, kind of makes sense to make this customizable as well, because that you can just set both of these to 0, and then effectively you don't need to print anything, right? Yeah, I would say let's go to main. So we have print asmlen. Let's do print bytes count. Print CPP or just source print source how do we call it? Line codes. Codes code len line len. Well, that's a bit ambiguous. Codes line len. Maybe call it source code and source line. Source code, source line, bytes. Let's put the bytes up here. Okay, so print intent. Okay, so 1, 2, 3. So we have bytes len and source code len, source line len, max character count. Max character count for max byte count printable max printable byte count for assembly instructions. Max printable Default is 11. Okay. Okay, source code len. Max character count for source code. Max character count for source file line. Default is six. I think this we can make. I would say for consistency, we just keep it at 32-bit values. Could be smaller. Okay, we'll be right back. Okay. Okay, so source code in comparison, text is truncated. Byteslen. Okay, so we will be able to set the byteslen and all this to 0, and this will effectively hide this, right? Okay. Then byteslen, source code len. Okay. Then we have bytes len, bytes count. Let's call it byte count. Byte count. Bytes count. Okay, byte count, source code len, and actually let's source line len we should put on 5. Default is 5. Source line len 5. Byte count is 11. Okay, then we go down here. We make copies of this. And we have, oops, byte count and source code len and source line len. Then we have byte count, source code len, and source line len. Okay. And then we pass it here on comparison options, ASM len. Bytes count, source code len, source line len. Wait, this is 11, 5. Okay. Mm-hmm. Okay, this should be so far so good. Good, then let's see how this guy is used. Yeah, here, processes. Okay. Output comparison results. Okay, so basically here we need to pass these guys. We pass a lot here. That's okay. Well, might as well just pass the whole options, right? I mean, what else is in there? Let me see. Put fire, format. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 settings in here. And here we pass 1, 2, 3, 4, 5, 6, 7, 8. Not all. Okay, so ASM len byte count source code len and source line len. Okay. Good. Then we take these guys. How about we put indentlen here before ASMlen, like that. And here we do it's a bit much arguments, but okay. Okay, comparison results. Put that here. Move this guy up here. Okay. So we have a byte count, all this good stuff here. Then we need to pass it on. Here. Let's also pass it here. Maybe we should have a struct for these things. Maybe not. Maybe another time. Okay, so byte count, printer, byte count, byte count. Good. Okay, and then here runner to pass on these guys here. Byte count that. Okay, source line, yeah. Okay, so the first thing we need to do is so here we can say if source code, if source line is not 0 and source code len it's not 0, then we do this, and here as well. And here, append bytes, here we say if byte count is not 0, let's do a larger 0, just in case someone changes it to unassigned integer for some reason. Okay, if byte count larger this and that, if byte count larger this and that. Good. Here on the append assembler, we have in asmlen so our truncate in place, let's say we pass asmlen 0. I think what this translates to is that it will show 2 dots. I would like to get rid of this STD max thingy here. The problem is if this is 2 or 1, if this is 1 or 0, it will go to 2. Hmm. 0, 2, 2, 2. So it's I don't know, it's, for robustness sake, this makes a lot of sense. But basically we have two conditions now here. This one condition, there's another. Can we maybe make it more efficient? Or is it a condition? Probably. Maxlen. Yeah, we can directly compare this with 2 here. How about we just make this smarter here? So we say for well, for size t I equals maxlen minus 1 3 size and string on 2 dots. Okay, let's remove this here. Yeah. So maxlen is not, it's not raised to 2. Okay, so this is okay, right? If maxlen is 0, it just resizes to 0. And here it would just erase the whole thing from begin to end. But then this would be illegal here, and this as well. Okay, but if we make a loop here and say, so maxlen, we can say for make a counter int I smaller than 2, and maxlen smaller than, no, it's not 0. Maxlen, let's put this first. Maxlen not 0, and that, and plus plus I, and then and minus minus maxlen. And then we put here maxlen minus 1. We leave it like this. Like this. Will this work? Maybe. Let's see. I maxlen. I think that this is correct. Oof. Let's put breakpoints here. Okay, so we have maxlen 86. Let's put a breakpoint in here. Okay. So here we have a code line or something. And so it will be truncated, and then so maxlen is not nearly at that. So now it will put this at the end, str 86 minus 1. So it puts a dot at the end there. Then it increments I, and it decrements maxlen, and puts another dot. Okay, so this is correct, yeah. And here here it should put the 2 dots at the start. We have maxlen this, maxlen this. Okay, so if maxlen was 0, then this would quit immediately. If this was 1, then it would enter here once. And this would be 0 now. And yeah, it writes the first. Then this decrements, and if it was 0, it would exit here. Otherwise, it can do it another time. Yeah, I think this is correct. I think this is correct. Yeah. Okay, this is much more elegant. Yeah, this is a much better algorithm for this function. Good. Then what we can also say here is maybe we should change the address len to 8 plus 1. Then remove this one space, yeah. And then we say here, if ASM len and here as well, if ASM len is larger 0. Yeah. Okay, so at a minimum, it will always print the instruction address, but can hide the actual assembler. But is it really worth it to do this check here? I mean, it will basically just do a lot of obsolete work if this was 0. Then it would basically... It would generate the instruction and then it would truncate it to 0, right? Yeah, I think this is okay. Okay, let's see if this compiles already. Yeah, good. Then here we pass. Okay, UN32 T. So this is source code len and source line len. Source codes, byte count. And here's UN32T bytes count. Okay, then here we put byte count. And move this byte len, byte count, yeah. Do byte len. Oh, it's called bytes len. Bytes len. Okay, so here's byte count. Bytes len. Where's this used? Okay, remove this. Then we move this here. Make it const. What is this? Count, okay. And here we have this guy. Okay, then we simply remove CPP line len. Where's this used? Yeah, okay, so here we need to think now how we do this here. Trunk front. So I would say we do here source code len plus equals 1 for the colon symbol. Then we remove this, move this, source code len plus 1 for colon. So we have source code len and that's source line len, truncates, yeah. Yeah, truncating this doesn't make so much sense, but yeah, so basically we would have to truncate this here. Truncate source line len plus offsets. This has to be moved here. It's kind of stupid though, because it truncates at the end. Do we even need the misc buff here? Yeah, I think this is wrong here. Actually, no, it's not, because we have this offset here. No, this is correct. We can do the same here. We don't need this misc buff. Instead, we do line. Line dot append this string, and then truncate plus offset. Then we remove this, this, line, dot append, to string, and plus offset. And remove this. Okay. Okay, but here, pad white space. Source code len, line len. Size len. Truncate in place. I would say we simply do okay, so we do buffers dot miscbuff dot assign, and then we do if miscbuff dot size is larger than this should be line, source line, is larger than that, then we erase here this, erase 0, size, len. Remove this. Okay, and then so it would truncate from the front, essentially. Truncate from the front line. So let's do if source len is larger than 0, then, only then we append this one. Okay, miscbuff. And then we do line dot append miscbuff. There we go. Okay, I think this works. Yeah. No, it doesn't. Oh, right. Need to pass some arguments here. Source code len, source line len, and same here. And bytes, byte counts. There we go. Good, so this compiles. And yeah, I think we have everything in place. Okay, let's see if the status quo still works normally. Okay. Yeah, that looks normal. Okay, now now this here is how we have made smaller. That's okay. Okay, so now let's see what it looks like when we start to shrink things. Okay, so indent len we have set to 2, ASM len 60. Let's put ASM len to 0. Then we do print byte count 0. Then we do print source code len 0 and print source line len 0. Okay, so basically a lot of stuff should not show now, essentially, right? So it should only show addresses and the comparison, like if they match. That's all we should be able to see now. All right, let's see. Okay, it doesn't crash, it's good. No, it doesn't look as I have expected. It still shows this. What did we do wrong? Something is wrong. Ah, I know what the problem is. Here we didn't pass the new things. Byte count, source code len, and source line len. Okay. Okay, this should work now. Okay, there we go. Yeah, this works. It looks kind of ugly. It looks a bit ugly because some spaces here at the end. Ah, it still puts the indent. Hold on. Indent. Can we fix that? PDB. I have idea. ASM printer append assembler here. How about if ASMlen is 0, then indentlen is 0 as well. Yeah. And then ASMlen indentlen. Addresslen. How about addresslen? Let's do the following. Line append push back. So let's do addresslen. Okay, let's do addresslen equals 8. And then we say if addresslen is larger than this, then ASMlen plus equals indentlen plus 1 for spacing between address. Okay. And then we remove then we move ASM addresslen plus ASMlen plus offset, and the same here. Okay. Yeah, I think this is correct now. Okay, so this should now show us just address and the comparison without any white space in between. Should be clean. No, there still is white space. It still shows the indent. Why is that? Oh, because here. That way. There we go. Okay. So that's the minimum, the minimum possible visualization here at the top. Yeah, I mean you can still see. Okay. So that's the smallest we can print. Okay. Then let's put back the so let's put ASM length to, let's say, 10. Run this. This should now show us a very dense assembler. Yeah. Okay, this is correct. Yeah. This is good. Okay, then let's add byte count. Let's say 3. Mm-hmm. 3 bytes. Yeah, that looks correct. I do wonder what happens if we put an astronomical byte count. Like, let's put 20. Does it actually do that? Yeah, it does. Okay. So we have a little bit too much bytes there. Let's clamp it. 10 bytes. Byte count. Let's do byte count equals std max byte count and this ASM instruction bytes array max size uint32t. There we go. So this should cap it at 11 length. Let's run this. No, did not. Oh, it put it at max. Hold on. Min, std min. There we go. Run this again. All right. There we go. Okay, this is correct. Yeah, looks good. It's a little bit dense here, but yeah, if we want it compact, that's what we get. Good. Then let's go to source. Source line len. Let's put that to 3. So we just want to see 3 digits of source lines. Let's see. doesn't show. I think that's because we made a mistake here in our condition. Here. We need to say if one of these, we can simplify this. If these together are larger than 0, let's put it here. Const source len. You insert it to T, source len, add these two together. If source len is larger 0, and the same here. Yeah, this should fix it. Yeah, there we go. So it now shows us a truncated line length. Okay, this is a bit unexpected here. Like, why is this? Append source code. Probably because I'm not sure. I suspect because here we have some C++. Ah. Okay, so I think what we need to do is we need to use our MISC buffer here. How do we do it? Assembler. Okay, I think I know what the problem is. We need to use a MISC buffer actually, yeah. So MISC buffer dot assign, and then we truncate the MISC buffer with source code len. And then, do we still need the offset then? No. Well, for this. And then we do line dot append MISC buffer. There we go. This should work. Now it's fixed. Okay. Then Yeah, looks good. Then let's dial up the source code length to, let's say, 20. Run this. And that will be yeah. Looks good. Yeah. There's now just one more question. What about here? So if our, let's test this. If we put our ASM length to 1, or 0, I don't know, 1. Let's put it to 1. Okay, it's unexpected that it prints 2 dots here. Truncate in place. Address len plus ASM len. Because it, for spacing. Because it, line append. Okay, I think what we need to do is here append white space. I think here we need buffers dot misc buff assign, and then misc buff truncate in place. Address len, and then line dot append misc buff. Can probably remove this thing here. Assign and assign truncate buffers. Truncate buffers. ASM len line misc buff. There we go. Truncate in place. Indent len. Okay, I think this works. Okay, so it is. Huh. Okay. Now that's a little bit unexpected. So our indent len. Wait, let's put a breakpoint here. Not yet. We have. Let's look at our arguments. So indent len is 2. And ASM len is 1. Okay. So it's 3 characters. Okay, then actually it makes sense. Yeah, and then we truncate that. So that's why it puts dot dot there. Yeah. Yeah, I think this is okay. I mean, I'm testing like the extreme cases just to see if nothing breaks. Obviously, it's not supposed to be used like this with these small numbers. Either set it to 0 or some reasonably larger number. But we still should test that it does not fall apart if you put some weird numbers, right? That the logic is robust. Okay, but to me it looks like that we have full control over the column width. We can remove them entirely. Yeah. There is another optimization we can do, I think, and that is in runner. Here. So basically, if o dot print source len plus line len, if that is larger than 0, only then build this. Otherwise we don't need it, so can skip it. And I guess we can do the same with this thing here. This is function matches. What does it do? Disassemble. Well, no, we still need the addresses, so we can't skip this thing. Yeah. Yeah, no, we can only skip this thing here. Comparison. Well, we can skip this here, no? No, we can't skip this. Yeah. No, we can only skip this here. Yeah. Mm. Okay, source code is still here. Yeah. Yeah, looks good. We didn't really test if the source code just prints fine on the other side, but I expect this works. And if it doesn't, then we can fix it later. Yeah. So basically, if the PDB was on this side, right, then the source code should be here on the right side, not on the left side. Yeah, but I expect this will be okay. Unless it isn't, which is possible. Good. Then, yeah, I think that's a good change. So, yeah, let's go through it. So we have, let's start at main. Print byte count, source code len, source line len, yep. Max byte count, let's make it larger. Max byte count in comparison reports. This is text is truncated if longer. Default is 11. Max character count for source code in comparison reports. Text is truncated if longer. Default is 80. Source line, default is 5. 1185. Yeah, this is all good. Then here byte count, source code, source line, that works. Then here byte count, source, yeah, we pass it on. Then runner, we pass this on. Runner, here we have the optimization. Here we just pass it on, and here as well. And then the ASM printer, we pass it on here and here. And here. Here we check if it's larger than 0. And only then we do this, yeah. Here the same for the bytes. And the same for these bytes. And for this. Yeah. Source line len, yeah. Misc buffer line, misc buffer line, append, truncate, erase. Yeah, good. Source line lens, okay. Byte count, byte len, yeah. Okay, count, yeah. But this is a little bit confusing here. Hold on. ASM printer count. Well, I will use, here I see the problem. It's shadowing this. I see. Byte count, std min. Byte count. Let's rename this to usable byte count. Yeah, good. All right, address len is no longer static, is mlen, okay. Clear is not necessary because we just assign. I need to clean. Is mlen assign. Good, so addresslen plus asmlen, okay. And here we optimize this logic. Accent, da, 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 da. Can we test this? Basically, let's make one run with source len. Print source code len, let's put it to 1. And then basically it should just print dots on source lines effectively. Yeah, so here one dot. Yeah. Yeah. Okay, that works. Then yeah. Then we call this add command line options for. We had such a change in the past. Here. Add command line options to control the max byte count, source code length, source code and source line length in comparison reports. Improve comparison reports logic. It's ASM printer. Improve ASM printer. Okay, add command line options to control the max byte count, source code, and source line lengths in ASM printer. Yeah, I don't think we have to do this. It's just implicit. Add command line options to control the max byte count, source code length, and source line lengths in ASM printer. Yeah. Control. Yeah. Commits. Okay, great. We did great progress. Let's push this. Okay, let's give a status update as well. Implemented command line options. Latest push to branch. Okay, good. Then next step. Now there's still here a question regarding undecorated name. So right now it only prints decorated names. But I don't really want to work on this right now. I think it's more important that we start work on the UI. Yeah. Yeah. So I guess next step, we look at how we want to do the UI. I already have a tool in mind, a library or a framework or whatever, lightweight, but I have never used it in a tool, so I don't know how easy it will be to integrate it, but I hope it is. Yeah, so we can look at that. It's github.com. Oh, not signed in for some reason. Okay. Yeah. Then I will now end this video here. Has been 2 hours 40. Yeah, we did good progress. Submitted all the pending changes and some new changes. And yeah, is there anything else? No. The next video, yeah, we will explore UI, how we kick that off. Yeah. Good. Then I wish you a great day or night. Until next time. Goodbye.